Okay, we are going to start by talking about what was in your opener. So you were given these two situations. You were given an algebraic rule for Rick's Rentals, and you were given an algebraic rule for Penny's Pencils. And you were asked what the different numbers mean. So let's start with Rick's Rentals. So if X represents the number of miles driven and Y represents the rental cost in dollars, and we look at the 0.10x, we're trying to figure out what 0.10 means. Well, 0.10 times x, that 0.10 is our slope, or our m. So 0.10 is our slope. And we want to think about what that means. Like, why would we be multiplying 0.10 times the number of miles driven when we were trying to find the total cost? Okay, and if you think back, we've done a couple of problems where we were talking about rental fees. This is 10 cents per mile driven. Okay, so that indicates 10 cents per mile driven, or the charge per mile. Okay, and then we have to think about the $22. Which the $22 that's being added, if 0.10 is our slope, then 22 has to be our y-intercept. So what do you think the $22 represents? Well, the $22 has to be some sort of cost, some sort of rental cost. And if you're not sure, you can always just say flat rental fee. So flat fee is a great way to just state what the y-intercept is. So I'm just going to say a flat rental fee. And what that means is when you say flat fee, it means it's only charged one time. Okay, the 10 cents per mile is repeatedly charged. So that's why it's per mile, and that's why it's our slope. Okay, so we're going to look at the same rule, but in Penny's Pencils. So X represents the number of pencils ordered, and Y represents the total cost of the order. Okay, so the position of the numbers has not changed. So 0.10 is the slope, and we need to think about, in this situation, what that represents. Okay, so it's not the cost per mile now. Now it's 10 cents per pencil. Okay. And then the 22 is still our y-intercept, but we need to think about what it means in this situation. So what would it mean in this situation? Well, if you're ordering a bunch of pencils, the $22 could be a shipping fee, or a flat order charge, or anything that would go along with ordering and delivering pencils. So I'm just going to say that it's a $22 delivery charge or shipping charge. And today what we're really talking about, we're really going to be talking about the context versus no context. So when you have a rule and you have a situation where X represents the number of miles and Y represents the total cost, versus just having what I call a naked equation with no context, no situation. Okay, so we're going to consider the rule, and I did rewrite it into y equals mx plus b form. So I switched it around a little bit from the two boxes above, just so it's easier for us to look at, because that's how we're used to seeing it. So we want to consider that rule, but it's not related to a real world situation. So it's not related. There's no context. We are just dealing with x and y. Okay, so if there is no context or no situation, nothing that these variables represent, true or false, could we use 20.5 as an input? Can we plug 20.5 in for x and get a y value? Yes, we can. And why would it make sense? Well, there's no context, so any value can be plugged in for x. No context means no restriction, basically. Okay, and now we're going to think about a negative number. So would -5 make sense as an input? If I plug -5 in for x, can I do the math and get an answer? Yes, I can, for the same reason as above. No context means no restrictions. So now we're going to take this a little bit further, and we are actually going to look at Rick's Rentals. Okay, so now we are dealing with this Rick's Rentals situation. Okay, remember where X represents the miles driven and Y represents the cost in dollars. Okay, so true or false, it makes sense to use 20.5 as an input for the algebraic rule. Explain. Okay, so remember what our input is. Our input is number of miles. Okay, so knowing that, can you drive 20.5 miles? Would it show that on your odometer? It would, so that makes sense. And if you're looking for an explanation, you can say that. The odometer shows fractions of a mile. I would have to go into my car to look at it. I don't know that it goes any further than 1 decimal place, but it definitely shows 1 decimal place. All right. All right, so let's look at the next one. True or false, it makes sense to use -5 as an input for the algebraic rule. So we're talking about miles driven. It makes sense to use a negative number for the number of miles driven. No, absolutely not. You cannot drive negative miles. Okay. All right, let's scroll up to the next one. Okay. And we're looking at the same rule again, but this time we're looking at Penny's situation. Okay, so we're looking at Penny's situation, and let's just write down what our input means. For Penny's situation, it's the number of pencils. Okay, so let's talk about it. True, false, it makes sense to use 20.5 as an input for the rule. Can I purchase 20.5 pencils? Does that make sense? No. You cannot buy a fraction of a pencil. You can't buy half of a pencil. Okay. All right. Next one. True or false? It makes sense to use -5. Can you buy a negative number of pencils? False. You cannot buy a negative number of pencils. Okay. All right, then you're just asked to make conclusions based on these 3 questions. And I think the biggest thing is when there's no context, there's no restrictions. I think that's the biggest takeaway here. I can put anything in for x, positive, negative, fraction, whole number, and I will get an output. All right, so let's take a look. One last thing we're going to do is look at the graphs. Okay, so we know that for Rick's Rentals, we said that it was okay to have 20.5 miles, but it was not okay to have negative miles. So which one of these graphs would better represent the inputs and outputs for Rick's Rentals? What do you think? Graph 1 or graph 2, and we need to explain. Okay, for me, I think graph 2 would be fine. And the reason being, you can have fractions of a mile. You can have numbers in between. So I'm looking right here at the first graph. It's only showing me the cost for 0 pencils, and it's only showing me the cost for 10 pencils. So can I buy between 0 and 10 pencils? Probably. So can I drive between 0 and 10 miles? Yes. So it makes more sense to have the continuous line. So I'm just saying it shows the numbers between 0 and 10, 10 and 20, etc. Okay, it shows all of the values. Which graph better represents the inputs and the outputs for Penny's pencils? I still think that graph 2 would work as well for the same reason. And I'm just going to say it a little differently so you see a different explanation, because we can purchase I'll say 15 pencils. And graph 1 doesn't show that. Okay. All right, last one, explain why both graphs only show data in the first quadrant. We should know this by now because we can't have any negative values, because you can't drive negative miles, you cannot purchase negative pencils. Oops.